We're going to be looking a little bit more at magnets now, and we're going to think about what happens when you break a magnet in two, and what happens when you connect magnets together, this idea of repelling. So I'm going to draw a slightly smaller version of a bar magnet here, and here we have a second one. Remember, each end is an opposite, has a pole, and the name of that is north, south, and for the ease of things we're going to put north and south here as well. Now we had a magnetic field line that was joining north and south in this way. We also have a magnetic field line that joins this north and this side like this as well. From north to south. And as we go along here, this is quite a strong connection. And we also have something that goes like so. And I won't draw the other side in, but just for completeness for this particular video I shall do so. Now when these two come together they actually attract each other. These force lines in the middle here join and create a single magnetic field. So in actual fact what happens, although it's quite tempting to think of it the way I have, oops, deleted too much, just do it a little bit smaller, is that these lines in fact join like so, and you end up with one magnetic field going all the way through and going all the way between these here. Now it wouldn't be very difficult to understand what happens when these two then join, as I will draw you the complete. If I let go of these two together, I have now one single magnet with north at this point. Oops. This is when these two parts here join together. That connection was here, but because they're now creating one continuous magnetic field like so, they're now behaving like a single magnet. If I then pull them apart again, into their original magnets, like so, each part of that magnet suddenly behaves as a north and south and north and south again. Now we're going to look at this one again on the left hand side again, and I'm going to break that one, maybe taking a chisel and chopping it in half, and what actually happens then is that we end up with two magnets half the size of the original one, and I'm sure you can guess what they will be as I completed them. If you guess, but both of them will have a north end and a south end, well done. And this of course will be north, and this will be south, and this will be north, and this will be south, and there will be attractive field lines going between these. And if I join them together, I will get this. And if I join that together, I will get this. And this of course is because as we're breaking it down, we still have the idea of having little magnetic domains inside here. I'm going to just draw this idea of a mosaic, each one having a very small agreeing magnetic field around all of its electrons. And as we continue breaking this down, we will end up ultimately with what we spoke about originally, which is a little electron with a magnetic field that goes something like from here to here, with north being on the left hand side and south being in that side. And using our former definition, that basically means that you have an arrow pointing in, oops, wrong way, arrow pointing in that direction, oops, so it's pointing in that direction in the middle, like so. My apologies, a bit difficult and a bit awkward to draw on this one. And that's as we're breaking it down. As we join them together, we end up with bigger magnets, and so on until we end up with a large one. So this is when we're talking about attraction.